What's going on? It's Mr. Gustin back in the physics classroom. Today we're going to discuss the differences between what circular motion is and what rotational motion is, because on the surface, to the layperson who's not studying Newtonian mechanics, you're thinking like those things sound the same. If I rotate, I'm moving circularly. Those things are synonyms, but in fact, they are not. We studied circular motion during Unit 3 in our forces study, and so let's recap what circular motion was. Circular motion described an object that was moving in a path of a circle. This object's path was described by a circumference, right? Its path was 2 pi r. When I say x, I mean displacement, right? It's how far, or distance. It's how far it moved. Objects moving circularly were literally taking circular paths. They were objects that had a net force pointed radially inward. We called this a centripetal force. They also had a tangential velocity. They were objects that were moving tangentially to their path and had a perpendicular inward net force. This was something that wasn't necessarily speeding up or slowing down, but it was something that was constantly changing directions. These were objects that moved in a circular path. We described their motion, their distance, or their distance as 2 pi over r, or circumference, and we described their velocity as v tan, tangential velocity, which was the circumference traveled over the period. And the period was the time it took to make one circular rotation. This was not linear motion, but it certainly was traditional translational motion, right? There wasn't any rotating around an axis of rotation. There was a middle to our circle, and the forces were pointed towards the middle, but we were not talking about a fixed object. We were not talking about torques. We were simply talking about the circular path. Now, this is different when I think about rotation. If I'm going to think about an object that rotates, I might think about a wheel or a disc that has a pivot point right here that is fixed. When this object is fixed, it rotates completely altogether. Does it take a circular path? It doesn't really take a path at all. It's one object that sweeps. And so we would say this thing rotates with an angular velocity, or an omega. Its distance, we would say, is theta. And theta is the measurement of the angle, quote unquote, swept by the object. And what I mean by angle swept is if I were to go ahead and place a piece of tape or a sticky note right here, and this thing rotated all the way down to here, how many degrees would that angle have changed? Or how many degrees would that object have rotated? It's hard to see with this thing. I'll move it over a little bit. There it is. From here to here, if it sweeps, that's 180 degrees, or 3.14 radians. This is our measurement. This would be our angle swept. So it's not about 2 pi r as much as it is about how much have I rotated around my axis of rotation, okay? So these are the differences that we see here. Our velocity is 2 pi over r. Our velocity over here, if it's moving at a constant speed, is going to be change in theta over time. That's going to be my angular speed, and that will tell me how fast I am rotating. And so these are the primary differences that we have. Now, one cool example we can talk about is going back to when we played Crack the Whip. And Crack the Whip, if you remember, was 4 of us, and we all lined up holding hands. And apparently we're getting taller as we go. And one person really stuck their feet in the ground, and they said they're going to stay put. And then what we did is the person on the outside ran around our group. And as a group, we all ran together. Well, if I'm going to take this object as a circular path, I can look at 4 different circular paths. I can look at this path, I can look at this path, and I can look at this path. The 4 different people covered 4 different circular paths in the same amount of time. And so if I think about these various things, they all made their circle at different times. And we'll call this person B, C, and D. Well, person B has the smallest circumference, right? So their 2 pi over r for B is smallest. They have the smallest radius in this circle, therefore the smallest circumference, therefore the smallest tangential velocity. They're moving the slowest. And if I think about the largest one, I would say V tan for D is definitely the largest. This is 2 pi r for person D. Over the same period, they move the fastest. And you can think about this like you're in marching band, right? If you're in marching band and you're making a formation on the football field, and as you're walking in a sweeping motion, making a circle, the people that are on the outside of that motion have to take the biggest steps to keep up, and the people on the inside of that motion have to take very little steps to keep your shoulders in line. People need to move faster to complete larger circles in the same amount of time. This is circular motion. On the flip side, we have rotational motion. And if I think about rotational motion, I want to go bird's eye view. So now I'm going to say here's A, B, C, and D. From the top down, I've got my drone and I'm zooming in right here. Here's person B, person C, and person D. And they're all going to make this is a terrible circle, but they're all going to make this rotating, sweeping motion like the second hand on a clock around together my axis of rotation, which is going to be person A. If this is the case, and they make the same circle, they make a circle, they sweep through this rotating motion in the same time, well, how many degrees do they have? If I think about this line of people, and after a set amount of time, they're all here, this is their angular displacement. That's their theta value, but they've all made the same angle sweep in the same time. So if I think about which of these has the fastest angular velocity, they all have the same change in angle over the same time. They all have the same angular velocity because they're moving together. So the differences between circular motion and rotational motion is that circular motion is literally following a circular path, whereas rotational motion is taking an object and examining it as a whole thing that rotates around a pivot point or an axis of rotation. Are there similarities? You betcha. But there are some distinct differences that allow us to examine these objects in 2 different ways, and it's important that you keep those straight. If you've got questions, drop it in the comments, ask me in class, send me an email. Until next time, see ya!